Hey guys, it's Austin and we're back here in the shop today. I've got something a little bit different for us today, and it is my BMX bike. I've been riding my bike to school every day, and I noticed that the headset is starting to come loose because of the compression bolt for what they have in this bike, and I need to fix that. A lot of the newer bikes, they come with this threaded bolt, and that's what we're going to be installing into this, but it's not something that we can just tap into the forks and put in there, so I got to make a sleeve for this, and I'll show you that here on the lathe in a minute. But we'll get this thing taken apart, show you the current system, which is a star nut, which is supposed to be pressed into the fork, and then it holds down for the headset and clamps everything together, and you have a certain amount of preload on it. And like I said, that's been loosening up. The newer bikes come with this threaded bolt, the newer high-end bikes that is. I'm assuming a lot of the cheaper ones still come with this bolt. Though this bike is a little bit older, it's about a 2014. So they did not have this and this style bike at this time. All of the new stolen center bikes have this. So like I said, we'll be upgrading this one to this, and we're going to save a bit of money where we don't have to buy a new fork for the bike. We'll be able to do it here in the shop and do it right, and it's going to hold well and be a lot stronger. So let's get to it. So here's the fork. I will pull the wheel off this here shortly, but this is what we're dealing with. Hopefully that'll focus. This is a star nut in here. You can see the tack welds on here. Before I left for school, I knew this thing was messing up, and what I did was just throw some tack welds in there if this camera would stop focusing. You can't see it, it's out of focus now. Anyways, I threw some tack welds in there to ensure that that thing didn't move. It's still moving. So what's happening here, the tack welds are holding just fine. Now the issue is that the threads and everything are pulling up out of the star nut because the star nut is so flimsy. It's just starting, it's such a thin material, it's starting to pull those threads up. So what we'll do is we'll cut these tack welds out. It won't take that much. Pull the star nut out, and I'll make this insert to go in here, thread it on the lathe, and we will weld it in here. We've gone ahead and cut our piece in the bandsaw. This is 1" 063 chromoly, so it's pretty thin wall to begin with. We'll go ahead and just face both sides here in the lathe. Just makes it a little bit nicer to work with. First one was just that face cut, and this is just a little chamfer on it. And we'll come back in and just clean up the inside with a deburring tool. Once we're done here, we'll go ahead and get our tap set up. So this is an M24 by 1.5, and that's the threaded bolt that we have there. It's the same thread diameter and threads per millimeter. So we'll go ahead, we start with our first pass, and then we have to reverse it because it's important to make sure that we break off the chip. You can see here that the part's actually spinning a little bit. That's kind of the result of having such a thin tube here, and the threads are so large inside there that we're actually kind of grabbing the tap when it gets, when the jaws get around to those ridges where the tap's cutting. So it makes the part want to spin around. If we had a 6 jaw, it would be a little bit better for this, but this will work. So I don't normally like to do this. I normally put the tap into a tailstock chuck. But this is kind of what I had here. The tap was too big for the tailstock chuck, so I had to use a live center with a tap handle. Tailstock is locked down on the ways, and I'm just advancing the tailstock with the tap just by hand and putting a little bit of pressure on it, just so I know that the tap handle and tap is not going to separate, just so I have it still centered up and it's supported on the back side. And then the tap handle itself just rests on the carriage for the lathe. Here's the part. You can see it's all oily. I'm using that Odie's dark thread cutting oil, and it's all oily on the outside, which was part of the reason that it was skipping around in there. But you could see when it just got real thin there, it just wanted to grab the threads on the tap with the lathe jaws. We'll bring the forks over here to the mill, and I've got this set up on some parallels so that I can break through the other side and I don't get into the vise. This is a 1/2 inch end mill, and I went fairly large on this. I definitely could have went smaller, maybe 1/4 inch for a normal rosette, but I ended up going with a 1/2 inch because this is going to be where most of the holding is coming from, being that the insert itself is so thin and the forks are so thin. I'm going to hardly get any weld on the top side. So we'll put these rosette welds in here, and this is going to help us secure that part in there. We're just going to hold it a lot more secure. Here it is up close. We just broke through both sides there. Doesn't really matter where you did this, but I kind of oriented it having the fork centered up. Alright, there I've just pushed the insert into it, and then we'll bring it over to the welder and weld it up. Here it's welded up. The welds aren't exactly pretty. I was trying to be very careful not to warp the fork head itself here. And you can see the rosettes are filled up most of the way, and then that top part is welded. Bring it over here to the vise and just grind this smooth. You can see that the rosette wasn't completely filled, but I didn't want to continue welding on this because I didn't want to warp the forks like I had mentioned. There's a lot of contact surface on here, so that little part that's not contacting on the where the stem is not going to make a bit of a difference. Just clean this up with the die grinder here, and then I run the tap back through it because I welded to the top part, and because I have the rosettes in there. What it's doing is just pushing those threads around on the ID. So run the tap back through here, and I'm using the same cutting oil on this. Anytime you weld a part, you're going to need to run the tap back through it. And then same deal here, just remember to back up, break that leading edge chip off. Once I run the tap all the way through here, you'd see that I didn't tap all the way through because the part was sitting so bad in the lathe that I ran the rest of the threads on the vise here. We'll thread our threaded bolt in. See, it threads in nicely. And we'll go ahead and put the bike back together. Make sure it all fits right. Stem went on nicely. Go ahead and put our threaded bolt in. Center up the bars with the front wheel. And we'll go ahead and tighten it all down. Make sure that we didn't over tighten that threaded bolt. You can just feel when there's enough play and then to where there's zero play, and then when it gets too tight. So we're just in the middle there. And then here is the final product. Alright guys, that wraps it up for this video. Today we have completed changing this with a star nut into that. I hope you guys enjoyed it, and I hope it helped someone out there. Thank you.